Okay, so we've developed the Taylor series. Now let's look at some examples of finding some Taylor series, and also identifying, where those, what the radius of convergence is for those. So I'm going to start with, how about we start with, let's find a Maclaurin series for f of x equals sine x. Okay, and so we know that the coefficients, right, the nth coefficient will have this form. So what we need to do is get our hands on these. Okay. So A0 will just be sine 0 or 0. Okay. But what about A1? Well, the derivative of sine, right, is cosine. So we'll have cosine 0, which will just be 1. A2. Well, cosine, derivative of cosine is negative sine over 2 factorial if you want. Well, this is just going to be 0, right? And then A3, well, what's the derivative of negative sine? Well, it's going to be negative cosine. So negative cosine 0 all over 3 factorial, which would be, negative, sorry, lost my pen here, negative 1 over 3 factorial. And what do you notice here? You should notice that the odd terms, right, are going to involve sine of zeros. I'm sorry, the even terms are all going to involve some type of sine 0, which will just make them 0. And then the odd terms, right, we had 1, negative 1 over 3 factorial. This now will be positive 1 over 5 factorial. A6 will be 0. A7, right, will be, well, negative 1 over 7 factorial, and so on. So how, let's think about what this looks like at this point. The sine x, if I want just this 7th order Taylor series, or Maclaurin series, polynomial, then I've got this 1x minus x over 3 factorial, plus, I'm sorry, x squared over 3 factorial, right? Oops, what am I doing? X cubed over 3 factorial. And then A5 is 1 over 5 factorial, so x to the 5th over 5 factorial. And then minus x to the 7th over 7 factorial. So is there a pattern here that we notice? Well, it looks to me that we've got a couple of things going on here. All right, first of all, I don't care about all these 0 term coefficients, right? Those aren't going to actually figure into what my terms are. So what's going on in my denominator? Well, it looks like I'm taking all the odd denominators, right? And so 2n plus 1 factorial. And do you agree? Let's think about this. If n is 0, then my denominator is 1. If n is 1, then I get 3 factorial. If n is 2, I get 5 factorial. When n is 3, I get 2 times 3 plus 1 is 7 factorial. And then my numerator, x to the 2n plus 1. But then what else is happening, right? This is alternating. So I could write this as -1 to the, well, the nth, right? And n is 0, we have +1. When n is 1, we have negative. And n is 2, we have positive. Okay, and so there we go. Now, what about the radius of convergence? Well, how about we look at the ratio test? We could do that, right? So let's look at x to the 2n plus 1 over 2n plus 1 factorial times, and then x to the 2n plus 1 and 2n plus 1 factorial. The limit as n goes to infinity, okay? And we know that we want this thing to be less than 1. And yeah, technically I'm absolute value, right? Okay. Well, let's play around with this and see what happens. I'm going to get the limit as n goes to infinity. Well, I've got an x to the 2n plus 1, and I got an x to the 2n plus 1. So really, right, this is going to cancel with all of those. I'm just going to have an x. Now, what's going to be going on here? Well, we'll have a 2n plus 1 factorial. And then after that, we'll just have canceling with this 2n plus 1 factorial. So really, we get this, right? And notice, this is independent of x. So 2n plus 3, this thing equals x times 0, so we get 0, which of course is less than 1. And so the radius of convergence then is the entire real line, okay? Because again, this is for all x, right? There were no x's that came out of this inequality. There was all of them that came out, okay? All right. Why don't we try another one? How about we look at something like Maclaurin series expansion for x sine x. Now, what's interesting here is we know that sine x, right, from the last one, is going to be -1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Well, how could we then look at x sine x? Well, x sine x will just be this. And what we want to do then is for lack of a better word, bring x inside the summation. But why am I allowed to do that? Because really what I'm saying is that I'm distributing over an infinite sum. Well, I'm allowed to do that because what do I know about this series? Right? It converges. The radius of convergence is infinity. This holds for all x's. So I have x times some finite value. So it's perfectly fine to absorb x in here and get -1 to the n, x to the, well, 2n plus 2 all over 2n plus 1 factorial. Okay? All right. So those are a couple examples of using, and well, specifically the Maclaurin series. And what we're going to do more of is, and what I would encourage you to spend some time working on, are Taylor series at non-zero centers, and looking for various radii of convergence. So what's next, where we're going to go next, and what we're going to discuss together next will be, and when you're able to get in groups, we'll be looking at some of these and applying differentiation or integration to helping get these expansions, and just kind of playing around and building some intuition with these. Okay, so the big picture here is still we have a power series, but now we know where the coefficients come from. Okay, I will see you soon.